Jasmine,
Dalia?
you're my sister, right? Do you give me permission to videotape you for academic purposes only?
No.
What?
I mean, yeah.
Great. Awesome. Let's get started.
I know which liquid will melt faster if it's frozen. I mean, I know that soda's denser, so it's probably going to melt slower. And I know that water is lighter, so it's probably going to melt faster. Let's do an experiment. Isn't it just coincidental that we have this equipment like right in front of us to test it out with? Wow. Okay, so I have these 3 containers. They're completely dry, same size and everything. Now I'm going to take 3 Coca-Cola ice cubes and put them in 1 cup. That's 1 cup. Now I'm going to take this one and put 3 lemonade ice cubes in 1 cup. That's another one. And the last cup, I'm just going to put regular water ice cubes. Okay. So now let's see which one melts faster.
Okay, so before we see the results of the experiment that we're doing, we're going to go back and go through the procedure. So first, we're trying to ask which type of ice cube melts faster. So the hypothesis for our experiment is if water, lemonade, and soda, in this case specifically Coca-Cola, ice cubes are left to melt, then the soda ice cubes will melt the slowest because they are denser. The independent variable is the type of ice cube, and the dependent variable is the rate of the ice cubes melting. So the things that we're keeping the same. So first is the temperature. The temperature inside the house is 65 degrees Fahrenheit and it's staying the same. The ice cubes aren't moving, and so the environment isn't changing for the ice cubes. And the size of the container is the same. So we're using this container, which is just this cup. There's nothing in the cup. It's dry. There's nothing in it, and they're all the same cup. The materials we're using is the ice tray. We're using the same pink ice tray that we put the ice cubes in. We have water, lemonade, soda, and again the container. And we also have a timekeeper. This can be either a phone or a stopwatch. We're using a phone. So how we did the procedure. So first we put liquids in an ice tray so that at least 3 ice cubes will be made of each liquid. And then we put the ice tray in the freezer so the ice cubes would form. Then the next step we did was we carefully extracted the ice cubes so that the ice cubes wouldn't break. And then we set the ice cubes in an empty container. That's this that we're talking about. And then we left the ice cubes undisturbed until they have melted. And then we're keeping track of the time to see how fast the ice cubes melt. So we're talking about what kind of reasoning are we using. So the first type of reasoning that we can use is inductive reasoning. That's when you look for a trend or pattern and you use it to generalize. This, of course, does not always mean you are correct. So an example of this is if we have Harold, and Harold is a grandfather. Harold is bald, therefore all grandfathers are bald. So that's inductive reasoning. And then the second type of reasoning is deductive reasoning. Deductive reasoning is when you take some set of data or facts and use it to come up with other facts that you know will be true. So an example of this is back to Harold is if we say all men are mortal. Harold is a man, therefore Harold is mortal. So that's for this experiment, we're using inductive reasoning. We're saying that because we know that soda is denser, that will melt slower than water. Yeah. Okay, awesome. Okay, the results are in. We measured everything. For the water, there was an entire ice cube left, and only 1 ounce of water was actually melted. The soda, there was no ice left, so the 2 ounces of soda was completely melted. And the lemonade, there was half an ice cube left, but 2.25 ounces of lemonade was melted. So our hypothesis was actually wrong. The soda ended up melting the fastest in the 1 hour that we gave it, and the water ended up melting the slowest. And we think this is because the soda had a lot of air pockets in them. So this concludes our analyzation of our experiment. So before we go, we want to talk about the differences between a hypothesis, a theory, and a law. And a hypothesis is a tentative explanation, just like the one we gave earlier, that we can use as an experiment. A theory tries to describe what nature does under certain conditions, and it's actually a mathematical statement. An example of this is E equals mc squared. And a law tries to explain how nature works. This is a non-mathematic, and an example of this is the quantum theorem. Okay, so thank you for watching, and bye.